Okay, can. Now it's ready. Okay, I share back my screen. My screen recording is on my computer. So I will reshare the screen back again. Okay. Yeah. Okay. Can y'all see back my LabVIEW screen? Richmond can see.
Yeah, I can.
Can okay, go. Can. Yulong and Han Chong, feel free to chip in. If you're not any part you're not sure, you can just anytime stop me when I'm explaining something. If you're not sure, sir, can you explain again that part? Okay, no problem. I'll go slow and go patient. Okay, so what I want to share with you, let's say for example, okay, I want to create a small program to do counting. Okay, so I will try to do two small programs this morning, short bite size, two small programs. One is to do counting. Okay, so let's say imagine you all know, like I just give you an example. A counter. You all know what's a counter? Okay, I just give an example. Let's say I just give an example. Let's say you go to Google. Okay, I show you a simple one. Then I want to make sure you all understand what we are doing. Let's say conveyor belt. I'm not sure if you know. This one doesn't mean that this is not useful one. Okay, let's say this is to give you idea. Let's say let's say I just randomly pull out a system, conveyor belt. Let's say counting. Let's say milk bottle. Let's say milk bottle, just to show you. See whether give you an example. So basically, what I'm trying to tell you is that okay, I see whether got this. Okay, let's say a simple example. This one, that's a simple example. I just randomly pull out one from internet. Okay, so you see this picture right on the right hand side. Slowly. Can you all see? The thing will refresh a bit slow.
Yeah, I can.
Can see. Okay, what you all see there? You see on this right side? Do you see a system like this, conveyor belt? Do you see a motor one?
Yeah.
This picture. Okay, so there's a proximity sensor, right? For example, something like that. Just an example. Now the idea is, let's say I want then you see this. I think this is a very good example. Okay, this one is quite nice. Okay, this picture quite nice. Okay, so what do you see? Can you all roughly guess what this thing is doing? Maybe I just copy this. Can you all see what's going on? Sorry, I just share with you the link. Share you all the link. So let's bring you back to the just now the one. Okay, that's the diagram. This one. Okay, so what do you think? What do you think this thing is trying to do? Make a guess.
The object from Moto 1 drop inside the box in Moto 2.
Very good. Right. Han Chong, you all can see not? Can see. Okay, so basically what you see is that a simple system like a motor, right? Now there's this motor that has objects. Maybe it's some object, factory objects. I mean anything can be milk bottle or whatever. So basically there's a sensor that detects this object. Right. Once it detected an object, it will have a counter, right, to count the object. So let's say for example there are you see there's a show. This is like something like a simple GUI. They see start, stop, right? Then there's a counter reset. And then they counted 5 items. Okay, it can be counting anything, the box or whatever, anything. But how they created this counter? Have you thought about that? If I ask you to write a LabVIEW program to create a small sub VI to count, and then ability to start, to reset, counter reset. How you reset this counter? What will you do? I'm just trying to see. If I ask you, you all know how to do. Let's say, if I give you this, imagine suddenly I give you this small task. How to do? In LabVIEW, I want to have a counter. Idea, idea.
While loop, then case structure.
While loop case structure, okay. Then how to have this counter? So that this count value will increase. You understand what I'm trying to drive at?
Case will have increment.
True case increment.
Case.
Okay. False case? What do you
put the reset.
Okay. But then okay, you're somewhat correct. But how do you do the counter reset? I just wonder. This one. if I press this counter reset, this 5 I will turn back to 0. Imagine if you think about it, let's
The
say
shift register thing.
shift register, something to do with shift register, right? So that
Yeah.
you can let me snip up this picture. Okay, so that when you want to let's say on a factory or what, right, you want to reset your system, you can do that, right? You know what I mean? Let's say, for example, after one day already, your system want to reset, you can reset the counter back to 0. Then the next day is a new what do you call a new fresh counter value. Right? Let me just save this. Okay. Save, okay. Okay. So let's see how we can proceed. But you all understand what I'm trying to do? I want to have a LabVIEW counter. Okay, so take note. That's why I'm trying to explain this to you first, so that you all have an idea of what Dr. C is trying to tell me. Okay, so let's proceed back to LabVIEW here. Okay, I want to make this counter count. Okay, so maybe what I do is that I put the picture here. Later, if you want, I can share with you the picture. This one, I just purposely put this picture here. Okay, so hold on. I put this picture here. Later, I'll send this VI to you. After I'm all done, then you can try to understand and then try to, if possible, make your own. Okay, I put this picture here. I put the picture here first. Okay, so this picture that I just now snip one. Okay, I just put it here. I want to make so that you understand. Okay, so I put this thing here. Then okay, I call this one. I don't call this one the action engine first. I take out this one first. I call this the main program. Okay, this is my main task I want to do. Okay, I remove this one first. I save. Okay, I'm going to save this. Okay, I'm going to save it on my desktop. Create a new folder. Yeah, so if I'm too fast, please stop me. Please, you can just anytime interrupt me. No problem. If I say so you talk too fast or I don't understand, please slow me down. Okay, and stop me if necessary. Okay, or ask question. Feel free anytime. Just unmute yourself, then just speak. Okay, what's going on? Okay, let me just call this simple action engine. Not to worry, I will give this program to you at the end after the lesson. I will zip it and then I will send it to all of you. Okay, I call this the main call. Okay, so I created a main program first. Later then I will come back again. So this is my main program. Okay, so this is my main program. Main program always call sub VI or call sub program. Okay, so thought it might be useful. Okay. Okay, hold on. Alright, so let's come back to here. Now I will now create a blank VI. Blank. This is really the sub VI. The action engine is here. I'm going to create here. Okay, just now that one is the main program which I'm going to use later. Call this sub VI. Okay, so first thing first, decide on what you want to do first. So like what just now Idel say, right? You need a while loop. Definitely, all sub VIs or action engine requires a while loop. Okay, a while loop, and you definitely need a case structure. Okay, so I put a case structure here. Okay, so now decide on at the beginning what this action engine, what are the inputs and outputs. You need to think about this part here. Okay, what are my inputs? Okay, then what are my outputs? Okay, this is pretty common. Okay, in fact, all the sub VI must have, or the action engine. I will use the word action engine and sub VI interchangeably. That means that they are actually meaning the same thing. AE, okay, action engine. Okay, is the same. It's equals to sub VI. It's the same term, but they use interchangeably. That means they just change the name, but it's the same thing. Okay, what are the inputs? Any thoughts? What do you think are the inputs for this sub-VI? You must design, when you design your LabVIEW program, you must think about what is the inputs, what are the outputs of the system. Okay, or this sub-program. Just like when you do C programming or what, it's the same thing. What are your arguments? What are your input parameters? What are the outputs? Okay, so maybe I start first. I share with you something first. Okay, what you need, right, in order to make this case structure, rather than having this thing like true or false, it's not so good because only 2 states, right? So I need more. So what do? I right click, I use the enum. Always create this one. Always. Okay, always. I hope to see all your code got this thing. Okay, so look for this one. Call the enum. Zoom in for you. Can you all see? Enum. Okay, enum means enumerated. Enumerated. So let's show you enumerated. So let's go to here. Select this enum, select and drop. Okay, it's called enum, right? I will call this the functional state. Okay, functional states, I would call it. I would probably make it a bit bigger, something like that. Okay, I call this the functional state. Okay, now then it appears on here, right? Okay, I'll put this side here first on the block diagram. Now this while loop run how many times? May I know? Anybody? Run this while loop because it's a action engine, right? Or a sub-VI. Sub-VI run how many times? Anyone? How many times do you think a sub-VI will need to be run? Anyone? Any idea?
Until you stop it.
Until you stop. But if you say until you stop it, will it be like the main program?
Yeah.
Yeah.
But this one is
Run one time.
Yes. Okay, very good. Very good. Adele. Okay. Sub-VI, okay. Only run once. Yeah. Or run once upon call. You know what's the meaning? You all know what's the meaning? What I wrote here? What does it mean? Run once upon call. What does it mean? Anyone?
There's a certain trigger to it.
Okay, certain trigger to it, sort of. Yes, correct. Only run once when you call it. Okay, that means it's like, and a sub-VI usually, or action engine, it only does a specific task. Okay, it runs once upon call and it does one specific task. Generally speaking, one specific task. Okay, now let me give you an example. You all know what is I'm sure you know You go restaurant to eat, right? You see the restaurant got many staff, right? Okay, so what is the job of a waiter? Simplest one. What's the job of a waiter? Obviously, right? You all know, right? So an obvious job of a waiter is to serve, right? Serve the customer, the diners to come here for the restaurant to eat. Does he do cashier work? Generally? No. Okay, very good. But why? Because the waiter's job is very specific. Right? It does one job and it does it very well. It's supposed to do very well. I'm not sure if you have seen, like, you go to restaurant or some, like, in a maybe a hawker coffee shop, this coffee shop where you see the waiter come in, especially at night, right? Let's say you got big dinner. The waiter got to serve many plates on his hand, right? He has to carry three plates at one go, right? So he does that job very well, right? Because his job is very specific. A waiter's job is to serve, only serve. He don't do any other thing. He don't go and collect the cashier money, close the cash register, or neither does he do other thing. Go to the kitchen and wash plates and those things. He doesn't. He just do one job. Okay, and he does it very well. Okay, so same thing. An action engine or sub-VI is supposed to do one job and do it very well. Okay, so he don't get confused by doing other things. So you have to design a sub-VI or action engine that's such that it does one very good job, and he only do that only. He don't do other thing. Okay, so rather than you create a code, okay, now I just maybe sideline a bit. I backtrack again. Okay, I go to another thing I show you. Now, the last thing you want in project, okay, the last thing I want to see a student's project is that, you know what, I don't want to, I hope I don't see, I shouldn't see in your case. You all know what is spaghetti code. This is the last thing I want to see, okay, in a student. Because if you come to me with a LabVIEW spaghetti code like this, okay, I say bye-bye to your project. Okay, so you see, you see this thing, you take a look. It's very scary, you see. Do you think you can read? You see this code, scary. You go and look at this code on the right hand side. Can you all see?
Can.
Okay. Anchao and Yulong can see. Okay. So
yes.
Yeah, okay, good. You see, this code, if any student, right, let's say, or staff, he come to me, he say, hey Alex, can you help me? I got this software code that I written in LabVIEW. Can you help me to troubleshoot? Yeah, what do you think I will say? I will tell him goodbye. I'll straight away say goodbye to the person and walk away. Okay, because why? There's no way I can troubleshoot this code. Agree or not? This is called in LabVIEW, the community, they call the spaghetti code. You know what spaghetti, right? Spaghetti means like noodles. Okay, it's horrendous. Right, you see this horror. Okay, let me share you then so what is should be the standard. Okay, so LabVIEW, okay, object oriented design. Okay, so you should aspire. Okay, this is what I aspire. Okay, I like to see code, something in this form. Okay, let me share with you. These kind of codes are pretty good. This one is a nice one. There are many Okay, let's pop out. Okay, so I'm sure you can see. Okay, what you see right on this right hand side here. You see the codes. You see, so the codes are very nicely designed. Even and all of these are what we call like an action engine. Okay, an action engine, but don't go into object oriented. This one you have not learned yet. So don't when you see LabVIEW got object oriented, you don't go and touch first. Okay, so you notice that this guy's program, this kind of codes are very neat, and even the sub VI later I'll teach you how to make the icon. The icon also got color. Okay, they color and then they can make it such that it's very easy to identify. Okay, so these are the type of object so-called design that I aspire to want you to learn. Okay, so I think part of the FYP training, these are some of the very good ones. Maybe I can share you some example. Okay, they are very easy to read and very modular. So I hope you can try to understand what I'm trying to teach you now, because part of your training in this FYP is to also to learn how to write good programming codes, okay, as part of your training. Alright, okay, sorry, let's come back to here. So my job, okay, the requirement is that, okay, I coming back to here, requirement, so don't forget requirement. Okay, your job is you have been tasked to create a counter. Okay, so these counters, the task, okay, the task is to be able to increment. You know what's increment? Okay, increment the what do you call it? Okay, increment, maybe a decrement also. Let's just to share you. Maybe can decrement if I want to. Let me see if I can. Okay, decrement also can. And then also to be able to do a counter reset. Okay, counter reset. Okay. Alright, so it is able to do three things. If I can break it down for you. Number one, is able to increment. Okay, increment. Number two is able to decrement. Decrement means can go down on the count. Okay, or it can also do a reset. Okay, so something like that. Okay, so if you are still following, okay, let's see what we can do. So this is the requirement. Alright, so okay, so first thing first, right, in your functional state, you need to define the states. You need to define the states. Okay. Just before I forget, okay, just now you all mentioned the action engine need to run once, right? Just now I say, right, you need to run once. So what happened to the while loop here? Still haven't settled this one. Okay, so what do you do with the while loop? Do you put a stop button or do you put something else? What do you think? Stop button.
Local variable.
Local no lah. Try
Just the
not.
parallel one.
No lah. You create a constant. Okay, I tell you why. Okay, we create a constant and then we set this constant to true. Okay, this one. Because why? The constant must be.
When it happens, then it stops, is it?
No, you only run once. Okay, what it does when I put the constant true here, the while loop only execute once. If you don't believe, let me share with you. Okay, now you see this thing. Okay, so this while loop, okay, it will only execute one time. How to know? Okay, I create an indicator. You know what is this, right? This one is the counter, the what do you call it? The loop counter iteration. This
iteration.
One. How many times the loop will run? Okay, now let's see what happens. I say that this program only run once. How do I know? Well, very simple. You can turn on the light bulb. Okay, you see my light bulb here? I switch it on. Okay, I run this program. Okay, you see what happened. You only run once and then it stop. Do you notice? The initial count of the I value is it always be 0. It start from 0. It iterate from 0, then 1, 2, 3, 5, 6, and so on. Okay, so this thing you see, I'm not kidding. This one only run one time only. Okay, I run again. I run one more time. You see, it will run once and then it stop. So you see, I run. Okay. Okay, so when you run, right, your while loop here, the output here is true, right? Okay, so how the while loop works is that I'm sure you know already. So now you all take so many the NI badges. I hope. This one some of the question right in the batch. The while loop, right? The while loop will run. Okay, depending on the loop condition terminal here. This one is stop when true. Stop if true. Okay, if you do not know, right, you can always welcome to click on the detail help. Click on this detail help. Then he will show you the what is this function, what is the help. Wait, it's launching. Where did it go? This one sometimes quite useful. The context help. Then here. Okay. So if you're not sure, you can, this iteration, this thing, right, number 3 is called the conditional terminal. This one. Okay, it will stop when there's a true. Okay, you specify, we specify this one to be stop if true. So when it's true, it will terminate. Understand? I hope you can go and explore. So I put a true to this guy here. Always put a true. Don't put a stop button. Remember, a stop button means that the program cannot stop. This while loop will not be able to stop. Okay, it will not be able to stop if you don't put a true. Put a true to it. Okay, then it will only stop after one time because the sub VI only run once and stop. Okay. So let me go on a bit. Okay, this one very simple. This is a very simple program. I'm sure you're going to write more complicated stuff than this. Okay, let's move on a little bit more. Okay, so basically just now coming back to this counter. Okay, so I need a few states. So what I do is that I need your help in case you're doing this. Okay, if you are trying to follow me, I'm not sure if any of you are like opening your LabVIEW, you are trying to create this. I can stop for a while first. Are you all trying to do or you're just listening? Any of you trying?
I'm trying.
You're trying? Okay, you're trying. Okay, if I too fast, you say, sir, slow down. Slow down. I'm trying to catch up.
Okay.
Okay, if you're trying, okay, that's interesting. That's good. If you want to try later, also can. You can just listen first. Also can. So what you do is that in this functional state, right, I'm going to incorporate some states in this counter. Okay, so I right click first. Okay, I need your help if you are doing edit items. Okay, edit items. Edit items. You click on edit items. Okay, so this window will pop out, right? So this enum, now what it does is basically I want to put in the state's name. The state name will correspond to a value, right? Which LabVIEW will use this value to switch the case structure later. Okay, this thing is used to connect to the case structure, so that I got several cases. Okay, in a moment you will see. So let's start with, I call it initialize. Now, usually many things need to initialize on it, so I create one initialize state. Okay, zoom in for you. Initialize. Okay, are there okay?
Yeah.
Okay. Han Chong, you all try. You all, if you all just follow. And Yi Long also. Okay, just try. Okay, after I okay. Initialize, then I insert another state. Okay, I want this one, just now we say increment, right? Okay, let's put another one called increment. Okay, then I insert one more. Later I'll arrange, don't worry. I'll have increment. I put another one called decrement. We put the upper letter. Okay, something like that. Alright, now how to, and then of course I got one called counter reset, right? Okay, I want to call, okay, counter reset. Okay, so basically I intend to have these 4 states only, but I want to reorder. I want to make this one go up. So how do I do? How to make this initialize go right to the top? Very simple, just move up. Okay, move up. So I move up. So it is at the top already. Then maybe I want the increment one first. So I move this thing up. And I want decrement up. Okay, so then I reorder everything. So this is my final one. So called. Okay, so far. The enum, so this one. The first thing first. Okay, can if no, okay, good. Now, so then what do I do? After that already, right, you've done the states already, right? Okay, click OK. Okay, one more thing. Okay, now, before you do anything, okay, I want to do this thing. Okay, you connect this wire first. If you can, go to your block diagram, as you can see on my screen here. Connect this functional state to the case selector, the green color question mark. This one, the green color question mark. Click on this thing. You will notice that LabVIEW will automatically populate or update the states over here. You see? You see this thing called increment. But then if you use your tools palette, use your little finger tool, you can navigate. Use your little shift right click on your mouse. If you do not know, shift right click. Press the shift key on your keyboard, right click on your mouse. You will get the tools palette. Or if you are comfortable, just open view tools palette. That one easier. Tools palette. Then you put the tools palette. Then if you want also, you can turn on this thing called the automatic tool selection. This you click on this, you turn green. You see? I click on it, it turn green. So quite useful because sometimes the tools can automatically select for you. See, when you mouse over, the tools will change according to what is needed. So now I know that when I come to here, the LabVIEW will automatically switch the tool. Okay, so now, okay, if you see over here, I have 2 states only. What happened to the rest? Do you know?
Add case.
Very good. So what you do, right? You can right click on the case structure here. You can add case for every value. This one. Okay, try then add case for every value. Okay, so what it does is that it will auto populate. Okay, right, add case for every. It will LabVIEW will automatically populate for you all the cases. Okay, very nicely. Very nicely it will do for you. So there are 4 cases. Okay, let's go back to the initialize. So this is the default case. Okay, so let's check to make sure your cases are correct. So like that, the cases are all correct. Okay, so far so good. Okay, now I want to share with you one thing. Okay, if you created this sub VI, right? Not finished yet. I want you to make this thing the type definition. Okay, I will explain a bit later. Okay, what is this thing called type definition? I'm just going to type here. You don't need to do this. I just type to add on. I'm going to give you this anyway. Okay, I want to this thing called type definition. I just put a text only. What I did was I just used the A tool, the A text tool. This is just a text only, nothing special. Okay, I want to make this thing a type definition. This functional state here, this thing will be a form of a type definition. Okay, this is just a text here. Okay, type definition. What does it mean? Okay, type definition. Why I show you first. You select the functional state. Okay, you go to edit. Okay, go to edit. Can you click on customize control? Click on this customize control. Okay, click on this customize control first. Now, basically, this is a special file. This is a special file. Okay, now this guy, if you examine a type definition, this thing got no block diagram one. You see, if I go to the Windows, I want to choose block. That is nothing one. Okay, it's only a front panel. Basically, it is a control. Okay, but I want this thing very special. Is that it's a type definition. I will explain to you what it means. So help me select this one first. Type definition. Okay, help me to select this one, type definition. Okay, now you need to save it. You need to save this file. Okay, now in addition, this is a file on its own. This type definition is a control file. It's a very special file, a control file. Okay, you need to save this, and at the same time, you need to save your this sub VI. Okay, so maybe we save this one first. Okay, I don't know whether if you are trying Richmond, some of you trying, right? You go to file, you save as. Save as. You save into a folder, can? Just now I created on my desktop called a simple action engine folder. So maybe you save in a folder, maybe at your desktop. Okay, I call this.
Can repeat?
Can, no problem. Save. Okay, I repeat. Can, no problem.
Which
part? This part. Okay, can you select already? Or I start from here.
How to get there?
Okay, can, no problem. Okay, I close one first. Close everything. Okay, from here, right? Okay, repeat, no problem. Like that good. You ask and stop me, okay? Select this thing first. Okay, no problem.
Okay.
Select. Okay, wait, select this guy. Don't know this thing. Select already. Select this. You see this thing highlighted, right? This whole thing.
Yeah.
All dotted line highlighted. Okay, then you move your cursor to edit. Okay, edit. Then you select this thing called customize control.
Okay.
Okay, step by step. Sometimes I talk too fast. You have to stop me. Sometimes I realize I also, when I attend another lecturer who teach PLC, I go and do he talk very fast. So cannot catch his step. Okay, it's normal. But slow me down, okay? Slow me down. I will go slow. Customize control. So you click on this, right? You will launch this thing, right? Open up this control box, so called. Okay, this is a special file, as I say. It's a very sacred and very special, very special file that you must take care of. Okay, take good care of this file because this one is contain all the states, right? Right, all the states, right? This one important, right? This one, all the states there. So you must take good care of this file. So what you do after you open already, I sort of minimize into a tiny little box like this. Okay, I select this one. This one very important step. Make sure you choose this type def. Okay, you must choose this one. Don't choose other thing. Don't choose strict type def. Never mind. Just use this one and type def. I will explain why. Okay, you choose. Are they okay?
Yeah.
Okay, drink some water. Okay, type def. Right, can ready? Okay, are we ready to save? Go to file. Okay, happy already. We save this one first. Save as. Okay, so save as. I'm gonna save. Okay, so where do I save? Okay, just now earlier I created a folder on my desktop called Simple Action Engine. Alright, so I save it under this thing called functional state. I just give it a name. Han Chong, are you all following? Han Chong? And Yulong?
Yes,
Free,
yes.
don't be
have
scared, don't be
reviewed
shy.
this
Don't be
part
shy.
from the Q state machine.
Q state machine. Oh,
Yes,
okay.
the
Can. Okay. Never mind. Later, if you find this one, if I too fast, later you can watch my video. Then you can be sort of practice again. But you can ask me question. No worry. Okay, so I choose this I call it functional, the name called functional states. Now the file has a very special extension, okay, called .ctl. Okay, because it's a control file. Okay, I need to save this file. Okay, I save first. I explain later. I save first. Click OK. Now save already, right? This one save already. You can close. Okay, close this one. Okay, you will notice that he will ask you, hey, do you want to replace the original control with this new one? Say yes. Okay, I want you to, before you click yes, I want you to observe. You notice that on my before I click yes, I want to show you something. You see this one, you see the functional state. You see this, I zoom in. You see the blue color, the functional state, the object, right? The box there. You see the blue color box, right? Later you see what happened. It will change with a black color triangle at the top left hand side. In a moment you will see. You observe on your screen. Okay, so I click yes. Okay, now then I save. Do you notice something has changed? Do you notice something has changed? Okay, I zoom in. Do you see something has changed? I don't know whether you observe. I zoom in. I let the screen refresh. Can you see what has changed?
Got a black
left,
triangle.
top left.
Yes, top left hand. You're right. Oh, you're right. Okay, you're hearing. There's a black color tip. Black color right hand side. The left hand side, top left hand corner got one triangle. Black color one. This one indicate to me that this fella is a type definition. Okay, now I will explain further. Now, okay, so where is this control file now? Okay, I go back to my desktop. I'm using my Windows Explorer. Windows Explorer. You know how to launch your Windows Explorer, right? Press the Windows key and then press E. Your letter E on your keyboard. Windows key, press down on your keyboard, and then you press the letter E. It will bring up your Windows Explorer. Okay. So I'm here now. Okay, my simple action engine, right? This one there. You will notice that I just saved the control file, right? Just a few minutes ago, 1 minute ago actually. The functional states is appear. Now I also got, just now I created the main call. I don't know whether you have or not. I created a blank VI called main call. Just now I put one picture there, right? The conveyor belt one. This is the main call. Okay. One more thing I haven't saved. Okay, one more thing. I need to save this sub VI because I do later I forget to save. Then not so good. So I go now. I save first. Go to File, Save As. So I save this sub VI first. So I save as. Okay, so you will save into the same folder. I call this one. I call it AE. I call it AE. Then maybe I call it counter. Okay, you can call it any name you like. I like to call it something a bit more meaningful so that I can recall. Now, I've created many sub VIs or action engine over the many years of my work in teaching and all these things, project and whatever. So I got many sub VI that I created, so I can reuse these fellas. Okay, I got many. Okay, sometimes you ask me, I just straight away give you. So let's say you want timer, I straight away give you the action engine straight away. Then you can use it already in your program. Okay, so it's very powerful. So I don't keep creating the same thing over and over again. Waste time, right? I create one time, I can use forever. Okay, so called So I created AE counter. Then I'm going to save already. Okay, I click OK. I save already. So this counter now my I don't know about you my folder now got 3 files. Okay, I got one AE counter. I got one type, this functional state. Now remember, this functional state goes with this file one. Remember, these two work together. You cannot miss out the functional state. If you copy AE out without the functional state, your AE cannot work. Understand? This thing work as a pair. Okay, remember, it's better to organize the thing properly. This one. So it's dependent on this. Now you notice that this AE now got 4 states, right? Okay, 1, 2, 3, 4. Now, what happens if somebody say that, hey, maybe one day I come in, I ask one of you, hey, can your AE, can you add one more state? Then what you all going to do? Can add or not? If I ask you, can you add one more state? You think can? Can, you know?
Cannot.
Can add. Can add another state. Cannot. Now got 4 state, right? But if I want to change how? I want to add 2 more states, can not?
Can.
You can. You just edit the enum. Okay, you can just open up the type def, edit the enum, then you will change another extra state if you want to. Okay, but never mind, for now we don't need. We start from here first. Okay, I'm going to increment and all these things here. These are the 4 states. Okay, so what do you think I need? This is a counter, right? So a counter, I want to create a numeric, right? Okay, I create a numeric indicator. Correct or not? A counter is a number only, right? Or not? Let's say just now you saw the example, right? The conveyor belt, the counter, there's a big number, right? Number 5, right? So I want to create this counter. This number can change, of course. So I create a numeric counter. Numeric indicator, indicator. So I create this indicator, I plonk it here. Okay. Now, do you think I need a data type in this form? I just wonder. You all know or not? This one. What is orange color means? You all do the NI batch, right? Now I test you. What is orange color mean? Anyone? What is orange? How come got some orange, some blue one? Let's say I got these 2. Okay, I duplicate. You know how I did this? I just share with you. You all know what I did? I just copy, right? I didn't copy and paste.
Press Control.
Very good, Han Chong. Thank you. I select this numeric control, the object. I press Control key on my keyboard. You all cannot see. I'm pressing my Control key. Hold on to the Control key. Left click your mouse and drag. You notice I can duplicate. You see? I can duplicate many numbers because I'm holding on to a Control key. You understand? So I just share with you. This is a little trick if you want to duplicate something. Okay, but I want to share with you. Okay, wait. Okay, what is the difference between these 2?
One is float,
Yes, correct. Very good. The
the
other
other
one?
is integer.
Okay, very good. Good. Wow. Okay, so you heard what she said, right? The orange one is called floating number. Okay, maybe I close my window first. You all hear a bit background noise, right? There's this truck downstairs on my block. Hold on, I close my window up here. Okay, sorry. Okay, I think you can hear me better. Shut down the background sound. Okay, and then switch on the aircon. Okay, so yeah, you're right. The numeric here. Okay, put a little text here. This is a floating point number. Okay, this orange one. This guy, right? This guy is a floating point number. I just use the text tool, the A2. I can just type. Okay, floating point. The other one is an integer. Integer type. Do you know the difference or not? That's the key point. Do you know what is the difference between these 2? What is the difference? Floating point and integer. Okay, so and in this example, right, this counter example, which one should we use? My question is any idea? Which one should we use?
Integer.
Yeah, integer. Why?
What is one object and don't have decimal?
Good one. Okay. So basically, you're right. This fella here is you know that counter, right? Counter, it's a numerical, it's an integer number, right? You don't have a 1.5 count, right? Right. You only have either a 1 count or a 2 count or a 3 count or so on, right? You don't have a 1.67 count, right? No such thing, right? So you're right. So I don't really need a floating point number. So why? Because also you have to be very careful with the type of data you choose. Because floating point is the you can right click and then you see the representation. Float DBL, double precision. I can't remember double means how many. What is the? I think it's 8 bytes. I think 64 bit. Yeah, 8 bytes of data. So if you use this, you are sort of like overkill. Not say you cannot use it. Not say you cannot use. You can use. LabVIEW still allow you to use, but you are wasting your resources. Do you understand? Because no point I use floating point number which I don't need, and I'm using 64-bit to represent this number. 64 bits is a lot, you know. 61 byte is 8 bits, right? Correct or not? So 8 times 8 is 64. So you are using 8 bytes of data to represent this thing. I think it's a bit silly, right? If you think about it. Right or not? So if you look at integer, you use 32-bit. Do you see it? 32-bit. 32-bit, how many bytes? You all know? 32-bit, how many bytes of data? 32 means what? 32-bit. How many bytes? 1 byte is 8-bit. So how many?
4.
4 byte. Yes, alright. 4 byte. Okay, 4 byte to represent this 32-bit number. Okay, so I think it's half. You can imagine it. Easily you save half this thing. So I don't want this one. I delete already. Okay, so I want integer. But I want this thing to be called counter. Okay, I call this counter. Okay, so I put this thing here. This is an indicator. I put it here first. Now, I want to start by initializing, right? Initialize. So what do? I right click, create a constant. Create a constant first. Okay, so do you think initialize means to put it to 0 or not? I bring this 0 inside. Do you think so? Is it correct? Do you think it's correct? If I put a 0 like this. So I put a bit of text here. Yeah, reset to 0, right? Initialize is a bit like reset, right? Or maybe don't use reset because actually okay, never mind. I just do first. Initialize. Okay, I just call it. Hey, y'all is good. Hey, I just share your LabVIEW code. Please include a lot of comments. Please, y'all, when y'all do LabVIEW, please try to put comments. The comments are basically for you and also for us, like your teacher, like Mr. Yuan. Mr. Yuan also can read a lot of LabVIEW code, right? Like me, like that. I need to understand what you are doing. That means your code. Okay, so I will initialize to. Okay, so initialize to 0. I put the text. Okay, initialize to 0. So I put the text here. Clean up the wire. Clean up wire. Right click on your mouse. Clean up wire. Okay, so this thing is right. Okay, so is this correct? What do you think? First step. Put a little comment here. Initialize to 0. Okay, so far so good. Anyone got any problem? So far follow or not? Or you're lost already? If you're lost, please stop me. I go very slow. Slow and patient. So far so good. Can?
Can.
Can So far okay I hope. Yeah, okay. So this is the first state initialize to 0. So I send a 0 to the counter here off it. Now at the same time, I want to right click and add shift register. I think yesterday Han Chong, you asked me a good question. What is a feedback node, right? Okay, so I'll explain to you here. Okay, I use shift register. Yeah, add shift register. Okay, you know what is that? So right click, add shift register. What is the purpose? Add shift register. Shift register is the one that can store the value. Okay, it can help us to store the value, to retain the data on the shift register, on the wire, and then store it here. Okay, for us to use it. So what I do is I wire this output of the counter here, I wire another wire to this shift register here, something like this. Okay, so far so good. This one, shift register. Now, your shift register, you don't initialize. Don't initialize to anything, okay? Remember, shift register is uninitialized one. This shift register is not initialized. Okay, it initialized through the program. So I would put a comment here. So it's uninitialized. Shift register. Hey, y'all have to, don't be shy, seriously. Y'all don't be shy. Y'all my student, y'all don't be shy. Y'all don't know, just say don't know. Or you're not sure. Please, don't. Okay, so don't keep quiet. So don't be scared. Okay, I'm very open. I'm very open to you ask questions. I don't school you I don't worry. Okay, so initialize. Okay, something like that. Okay, uninitialize. Something like that. Okay, uninitialize this shift register. Okay, so then after that, what's the next state? Okay, shall we move on to the next state? What's the next state? Increment, right? Right, increment. So what do we do when we go to increment state? I just show you here only. Okay, we go to here. So what you go to the next state, right? Increment. What do you think here? What do you do? Where's the value that is being stored just now, the 0 value? Where is it now? Just now you initialize. Imagine you run the first state, initialize, right? You pass the 0 value, right? The 0 value pass down on this wire, go to this counter display, right? The counter is here, by the way. This is my output. Okay, this counter is here. Okay, and where does it go to? Store in here, and then the value also go to the shift register. Remember, this one will store the data on the shift register. Okay, your counter value. Okay, counter value. Okay, counter value is stored in the shift register. Remember, this one, the concept of the shift register is very powerful mechanism. Okay, seriously, it's very powerful. Okay, oops, sorry. So I just make a text comment here. Okay, the counter value is stored on the wire, and the wire stores the data. Okay, let me just put some comments here. Okay, you don't have to put the comments. You all just try to understand and listen. Data register, okay, stores the content. Okay, then later I'm going to give this VI to you anyway. Then you can go and study this thing slowly. Okay, so the shift register's job is to store the content, the data. Store here. Your 0 pass to the counter. The 0 values pass to the wire, store on the shift register. Okay, so what is the purpose? Why you need to store? It's like a memory, right? Shift register is like a memory. It's able to store the information on the shift register like a memory like that. Okay, so that when you next time you call the next state, right? You go to the next state is increment, right? Okay, the value comes out from here. Okay, the data that you store, the previous data, okay, the previous data value, the previous counter value, right? Okay, it's stored, come from here. It comes from this shift register. Delete this guy. Yeah, this shift register. Okay, the value that from previous from previous. Okay, from previous value, the 0 value, right, is being stored from this, the other device, the shift register. The value comes out to here. Then what do we do here? We increment, right? That was the plan, right? We want to increment the value. So what do? Right click, go to numeric. I want to use the +1, the increment function. Select this one, put it here. Okay, then wire this guy to here, and then wire the input to here. Okay, so this one is called increment. Right, increment. So far so good, easy. Increment. Okay, then after that we are going to finish it. We go to decrement. Decrement means to reduce, right? So I select the numeric palette, go to decrement, decrease by 1. Just an example. Later you ask me, hey, so why you need a decrement? Well, I don't know. Maybe the operator, there's an operator there, then he can press the button or something like that, they can reduce the value. Maybe it's a rejected item. It's a rejected item, then it doesn't fall into the box. But you already accidentally counted it, so you have to decrease the value by 1. Okay, decrement. Then after that, the last one is what? Reset, right? Counter reset, the last state. So what do you do with counter reset? Anyone? Should be very easy. So what do you do here? Anyone? What is counter reset? I want to reset this counter back to original. So what do I do? What do we put here? Anyone? Some suggestion?
0.
I want to put to
0.
Yes, correct. 0. Reset the value to 0. Very good. So I right click, create constant, put 0. Okay. Now, be careful that when you create your action engine, now, usually, right, the shift register, if you want to retain the wire value, you must wire from one to the other, remember. You cannot leave the wire, let's say, for example, in decrement, let's say you don't want to have this decrement state, right? Imagine, now the tunnel value from the wire must be passed to the next value. If you want to retain the value, then what do you do? Okay, if I want to retain, okay, maybe, okay, now I want to add one more thing. Okay, I want you to add one more thing. So this counter, I noticed that there's initial increment, decrement, and counter reset. What happens if I stop my conveyor belt? I don't want the counter to increment. Then what do? I want to retain the data, or I retain. How do you retain the value? It means I don't want to increment, I don't want to decrement, I do nothing. I want to keep at the value. So I call retain. So how? Okay, this is the part. This is the interesting part now. Okay, I'm telling you now. Okay, listen. Okay, I want now you to add another state into the enum, which you can, because I created this as a function enum type. The type definition. Remember just now the type definition. Type definition means I allow to come back and edit the states because of the special control function here. Okay, so what I mean is that I now want to add one more state. Okay, I'm bringing you as an example. If you don't have enum type, you cannot edit your state. Then your program all crash already, cannot work already, so called, because you will corrupt your state. So what I mean is that I want to now select this thing again. I want to add one more state, which I forgot just now. Right click, edit, customize control. Okay, I want you to click on this one. Customize control, click. Okay, go back to the enum state. Okay, now I right click again, I edit item. Okay, edit item. I want to add one more state. Okay, I want to add one more state. Okay, I just click on this initialize. Okay, I insert one more state. Can you follow or not? You can follow, I hope. Follow, try to follow. Click, insert one more state. I want to say call retain. Retain value. Okay, it means that when I click on this retain value, the data don't change. I don't change anything. I call retain value. Okay, can follow? Click on OK. Then I move this thing down. I click on this one, move it down. So I got these few states. So now my enum has a new state that I just formally make one. Call retain value. Okay, can try? Retain value. So now I got initialize, retain value. Retain value means I keep the value, I don't change it. Retain value. Then I got increment, decrement, and counter reset. Okay. Okay, done. I hope so. Click OK. Now then you need to apply changes. Now notice that the LabVIEW grays out this thing. This thing is being grayed out. You see the background there is being grayed out because LabVIEW knows that you're editing. So what I need to do is I go to my file, apply changes. Okay, apply changes. Okay, apply changes. Then after that I save. Go to file, save. Okay, once you save already, you can close this thing. Close. Okay, so now I can have another state. Hey, where did the state go? It's not there. Then how? What do I do? How to get the thing? I don't have it. I don't see it. I change already. So same thing, right? Which one you know, right?
Add case after.
Yes, correct. Add case. You can add case after, or you can add case for every value. Up to you. It's the same. That's why add case for every value. Click on this one. Okay, then you go back and see again. There. Now I got this retain value. But if you want to reorder this thing nicely, like what you have in your enum state, you can. So what you do is that you select the case structure, right click, you can rearrange the cases. Okay, rearrange the cases. Click on this one. Yeah, you can then select this retain value. Then you can left click your mouse, hold the value, and then bring it up. You try. You select this. You see now this retain value is selected, right? You left click your mouse, hold that value, and then you slowly bring it up. Okay, so I bring it up to here, then I let go. There. You see, can I repeat again? Cannot repeat. Okay, never mind. I bring it down and then show you again. Okay, you understand what I'm saying? I'm trying to show you how to rearrange this thing. You select the one that you want, the retain value, right? Left click your mouse, hold on to it. Your mouse, your finger, your index finger, hold on to your mouse. Hold on to the mouse. Bring this value slowly up there. After you right to the right position you want, you left click, you let go your mouse. There. Okay, now rearrange properly again. So it's sorted out. So I click OK. Yeah, so it's now the same as the one that this condition, initialize, retain, increment, decrement, counter is exactly the same as your this one. Same arrangement there. Okay, same arrangement. Okay, so now quickly, last one very quickly. This one, I think you all don't try to understand what we are doing slowly if you takes time to get yourself familiar. But later after you do it, you will realize that wow, Dr. C, this one Alex so good that this action engine very useful. Later you will see the benefit. Now what do I do with this last one? Your program still broken arrow, You see or not? Why if I click broken arrow, you see what happened? Then he tell you LabVIEW prompts you an error. What did he say? Did you see that? What did he say? He said the tunnel missing value, missing assignment. So what does it mean? It means that one of your state is not connected. Your tunnel, do you see what's tunnel? No? The tunnel means this one. This thing is white color. It's not connected. You can click on this show error. Then he will show you here. Yeah. How? This one not connected. So what should we do? What should we do? Any idea? What is retain value? What's the purpose of retain value? Retain value, then you can close on. Retain value means what? I want to keep the value, right?
From
retain value,
previous value.
Yes, correct. From this value, click on this one, right? Then you connect to
your wire.
Yes, you must remember to wire to the tunnel. Remember, if you don't wire, right? If you leave it as default, I just share you. Okay, let's say I show you an example. If you don't connect this wire like this, okay, some people a bit lazy, they use right click, use default if unwired. What happens if you do this? Default, what do you think? What do you think will happen to your counter value? It will be automatically reset to 0. Okay, LabVIEW, if you see LabVIEW don't see any data that is coming from the tunnel here, LabVIEW will assume that you are putting it back to 0. You understand? So be careful. So this wire must be connected like this. Okay, so the counter value is retained. Retain means keep . Okay, retain, the word means keep. Retain means keep. Now, if you don't understand, let me know. No? Feel free to ask. Yeah, seriously, if you're not sure, just stop me and ask me. Or some of the words you're not sure, right? Then we, okay, retain means keep. Is keep. The same word. Retain means keep. It's kept actually in proper English. It's kept. Past participle. Okay, retain, the counter value is kept as the original. Okay, I think we can try this thing now. Okay, let's try. Okay, you can actually test out this action engine now. Okay, let's try and run this thing. I'm going to switch on the highlight execution just to show you, just to demo to you. Okay, so what happened is this. Okay, I'm going to run. I haven't finished making the icon yet, which I'm going to do. Now, usually when I make this program, I make it very, very fast but because of the explanation to you, I'm slowing this very slowly because I can make this thing in 5 minutes, very fast, without explaining if I do it by myself, right, I do it very fast, okay, because I'm explaining to you, that's why I'm going very slow. Alright, so let's try and run this first, okay. So the first initialization is you selected initialize, right? So I run this, so watch. See, LabVIEW will run the initialize. Okay, there you see, I don't know whether you can see or not. Just now you can just see the animation. Run again.
Yeah.
Because it's run through MS Team. The thing is like a bit lagging, I think. Okay, I run it one more time slowly. Okay, you see. Anyway, it's recorded. It's recorded. Okay. So the LabVIEW will run, it will switch to the first case called initialize, then the 0 value is being passed to the counter. At the same time, the 0 value is being passed to the shift register. So can you tell me what is stored in the shift register now? What is stored there?
0.
Yes, the value 0, correct. Very good. Now, if I now choose increment, what do you think happen? What do you think will happen? If I choose this state as increment, right? Yeah, it will change state, right? Because your functional state is increment, right? So your increment will come here, LabVIEW will change the state, right? Change to the increment state, right? So then your previous value 0 is being passed out from the shift register. Come here, 0 plus 1 output will be 1, right? And then the 1 value will be pushed to the counter, right? The indicator. At the same time, the data will be beside the 1 value will go into the counter. The 1 value also gets pushed out and goes to be stored in the shift register. Do you understand? Okay, let's see if this is true or not. I'm just going to put it this way. I'm going to click on the run button. Okay, watch. Okay, 1 is stored now. Okay, do you notice that the counter also gets shifted? Minimize this one. So that won't confuse you. Let's put this one on full screen. Right, yeah. Can you all see? Okay, do it this way. Can you all see? Like that, is it okay?
Yeah, thank you.
Okay, so I run one more time. So you see I'm going very, very, very slow already. Very, very slow. So it's now I run again. The value from 1 now become 2, right? Because it gets incremented. Okay, so as long as I keep the increment state, my counter value will keep increasing. 2 become 3. Okay, you see? 2 become 3. This value here, 2 become 3, and so on and so forth. Okay, so far so good. Do you understand?
Yeah.
And okay, then if I select, let's say decrement, what do you think will happen? If I select decrement means decrease, right? So what will happen? What is the value now in the shift register? Can you tell me?
3.
3, yes, it's stored there inside the memory in your LabVIEW. As long as your LabVIEW program is running with your VI open, the value will be stored in as 3. Okay, but what happens if you shut down LabVIEW? What do you think what will happen? Does it still store there?
Yeah.
Do you think so? Are you sure, Richard? Yeah. If I close LabVIEW, I totally shut down my LabVIEw. I shut down my PC. Then I reopen this thing. What will happen? No more already. The data will not be stored there. Remember. Okay, the data will not be. The data will only store in the shift register as long as your LabVIEW VI is loaded in the memory. Okay, do you understand? It will not store there permanently. It does not stop permanently. As long as your LabVIEW VI is being called, right, is in the system. Your VI, the LabVIEW environment is open, right? Your sub VI is, your AE is inside the loaded. If the value will be in the shift register. Else, if your LabVIEW is fully shut down, your shift register will disappear, all the value. Okay, so this one you must take note. You must take note, okay? Take note. It's a non-volatile memory. It's not a hard disk. It's just a memory when you are running on the runtime. The program will temporarily store your data only. Okay? Can please take note. Okay, so decrement, what will happen? Quickly. What is decrement?
-1.
Minus. Okay, if I run, it will minus off by 1 value. So you now show me 2. Do you understand? 2. So what happen if I now choose retain value? What will happen? Quickly. What will happen?
So you just remain at 2.
Yes, correct. So if I run and show you, the value 2 is passed down to the case called retain value. The 2 value passed down to the counter value. The 2 also passed back to the shift register, and now the value keep at 2. No matter what I do, I run again, the value will be kept at 2. Okay, understand? So far so good. Okay, you see I keep pressing retain value, the value will be kept at number 2. Okay, now the last one, counter reset. What do you think will happen? And I click this one.
0.
What will happen? Counter reset means what? Yes, it
0.
will reset the value to 0. Very good. Okay, so let me just demo to you. I click run. Okay, the state will go to counter reset. Now you notice that your counter value, focus here, counter value is reset to 0. Okay, very good. So generally speaking, I have tested this action engine is working. Do you understand? before you plug your this. Okay, not finished yet. I haven't done the icon, which I'm gonna do now. Okay, I'm gonna do now. Now, sometimes the program got this thing called error in, error out. I don't know whether you see it. You go to here, right? Go to the front panel there, array, matrix, and cluster. There's this error in, error out, right? It's a good practice to put this one. Yeah, put and show you. Right click, go to array, matrix, and cluster. This one. Okay, take the error out. Just now error in, right? Now I take error out, take and then put it here. Okay, so usually I would put the error in, error out like this. Okay. Alright, so if you want to be very professional, a professional programmer, right? If you want to be very good programmer, you usually must handle the error. Okay, error handling is quite common in LabVIEW. So maybe I just add one thing for you lah. Right click, you add one case structure. This one sometimes students very confused why I do this. You can put one case structure and close the whole code. The whole thing. Just do first. Later you go and think. I will explain and then you think a bit. I put the case structure around this whole code here. Something like that. Okay. Then I bring. Okay, I maximize this one first. If you follow. Okay, I got error in, right? Error out. Okay, now I put the error into the case selector here. Click. Okay, so it means that this one means no error. This case means got no error. It's working fine. Then I wire this thing out to here and wire this to the error out. Okay. Now then I go to the other case, right? Means error case. When there's an error, I don't execute. I wire through. Okay, what is the purpose? I think you're very confused already when I see this. Do you know why I do this? Any idea why I do this? Anyone? I think maybe you're very confused already, some of you. Why? What is the purpose? Why I have to add in this case? It's a very standard case. I will add one. After I created my action engine, I will put one case around it. Error in, error out. So what do I do? You make a guess. What do you think? Is there any logic doing this error? When there's an error, what do you do? No, I ask you a question. Okay, I ask you. I rephrase it for you. If I got error upstream, right? That means beginning. Here, the beginning part got error, right? Do I still want to run this code?
No.
No, right? No sense, right? Let's say if I give you an example, I try to bring you back to just now this example here. Now imagine these are milk bottles. Okay, imagine these are objects, right? It could be processing it like in a milk factory. Let's say these are all milk. Imagine it. Okay, so I ask you, if the milk come in is contaminated. Contaminated means got some maybe dirty things or some hair drop inside this bottle milk. Do you want the QC, the quality control, can you still pass the bottle?
No.
Cannot, right? Because there's dirty things or waste or some contaminants in the milk, right? My production should stop right immediately. Agree or not? I cannot let the consumer drink a contaminated milk, right? Maybe a company will gonna sue. Right, if I produce this thing, next the customer drink already, then got something happen, the company will be in deep trouble. Am I right? So if let's say your upstream here, your milk bottle got contaminant, do you still want your counter to count? I ask you a question. Or should you immediately stop? Immediately stop, right? So that means that your counter, can you still count? Do you still want to run this code to count or do anything? No, right? No. So you should, when there's an error, it will go to the error case. Correct now? It means error case, I do nothing. Am I right? Do you agree? I don't want to count already. I don't want to run this code anymore because it's upstream got error already. Upstream. How to simulate the error in the upstream? Let me show you. I show you. Okay. Maybe you see this one, you can understand better. Okay, go back to here, right? Now I can simulate error in my code upstream. Let's say upstream error. The code come to here. This is the error from previous. I call it the upstream error. Error from upstream. Error from maybe from a previous VI, from previous. Okay, because I'm going to create a connector for this. Later you will see. So imagine upstream from previous site got error. You come to here. I don't want to. I can simulate an error. I show you. You can try this. You can use the finger to click on this status here. The error in, right? You click cross. Okay, I click across means I simulate error. Okay, now I run this code. You see what happened. Now I run. Watch. Okay, watch what happened. You see. Okay, you will switch. There you see error no? There. Once there's an error, I don't want to run any of the code already. I will skip completely. Okay, so that I don't waste my time. Okay, I don't waste my time running this code because earlier, as I give an example, right, the contamination of the milk. Let's say I know the error already, but I don't want my VI to run. I will do nothing. But unless when there's no error from previous, which I check here, when I run. Then it's okay. The output will show okay. Then I can continue running the internal part of the code here. Okay. Now, if you don't understand this one, maybe you can ask me again. But I want to finish wrapping up this thing. Okay. So let's finish off this thing. Almost done already. So what I need to do is, okay, the last step. Okay, now coming to lunchtime already. Okay, soon. Some of you hungry. Okay, what I do is that I want to create an icon. Okay, so what do I do?
Sure.
Right click.
Sure.
Yes.
I have a question.
Yeah, question. Yes, ask.
Will the data still be stored in the ship register?
Yes, the data will still be stored there. Don't worry.
Okay.
As long as you don't shut down your VI, your data will be stored. Even though upstream got error, your data is still safely kept at the ship register inside.
Okay, thank you.
Can Okay, good. Alright, so last part. Okay, let's make the icon for it. So can you help me? Go to your front panel there. Okay, can you do an edit icon? Okay, help me. Let's do together. Okay, so I do an edit icon. Now I want to make the icon useful. Okay, this is the part. Okay, I want to make this action engine. I want the icon to be useful. I don't want to leave like that. This icon, standard icon, no meaning. So what I do is I click on this tool here. Okay, click on this tool. This is a selection tool. I select this whole part. I delete away this part. I select only this part. Be careful. Don't select the box. Don't select the boundary. The square box. I want to keep that box one. Only select the inside. Okay, selected already. I press delete. Okay. I should have the box still kept there. Remember. You should still see the square box. Drink some water. Okay, so then what do? I use the T tool, the text tool. I want to put the name. So usually I use the T. Now make sure your color is selected as black, the default. So I type here. I call AE. I call it A.E. Okay, keep it simple. Keep it simple. Maybe okay, sorry. Maybe we don't do the text first. Sorry. Undo first. We fill the color first. Let's say if I want to fill this box. Sorry. I fill the box first. So I use this bucket tool. The small little bucket there, right? The color one. So I select this one. Now I choose the color first. Maybe I like green. Let's say I choose a color. Not say I like or not like. I choose a color. I be consistent. Okay. Have a proper method and style. Okay, let's say if I choose green, for example. Okay, so I selected the bucket, right? I choose green. So I'm going to splash this paint onto here. So I click there. So I make sure I splash it all green. Something like this. Can you try? If you can, try to follow it. Okay, splash it green. So it's a green color. So maybe I use color to code to differentiate different action engine. So up to you. So you have a systematic way. Let's say if I use green color, I use green color for all certain functions. Okay. or maybe I use blue color, or maybe all for my mod bus, let's say for example. Maybe either you use Raspberry Pi, right? I use certain color, green color for certain function, then I use blue color for certain function. Mathematical function, I use all the blue color. Okay, something like that. Okay, so you try to use, don't use all the color all mix. Then I don't know what you are doing. So you use specific color. You tell me, oh, I try to organize my action engine such that green color refers to maybe I do something. You know what I mean? Then I use blue color to do certain set of data. Let's say I don't know. Maybe I got a lot of mathematical function. I use a set of blue color. Okay, and so on. So it's up to you to decide. Okay, now let's go back to my A tool quickly. I use the tool for the text. So I choose black because the text must be black color, right? So I choose text tool, then I choose black color, then I can type now. So I type A.E. AE, I call it AE. Okay, then for me, I like to use the line tool here. I draw a line here. Okay, cut here. Then I go back to my text tool again. I call this thing. This is a counter, right? So let's call it counter lah. If you can fit, sometimes cannot fit sometimes cannot fit. I just call it count. Okay, that's all. That's all. I try to keep it simple lah. Okay, keep it simple. Of course, you can go and play around. They got many this thing called layer and all these things. You can put all these nice little icon and stuff like that. See all this, but I usually don't bother. You can go and find up to you. Let's say for example, maybe your AE is to measuring temperature, right? For example, maybe I'm not sure. If you are measuring temperature, then you can look for one thermometer. I think they have all the different types. So many. No time to play. No time to play. You can go and play yourself. This one counter and so. Okay, so for me, I just do a simple AE, just text tool will do. Okay, I just click OK. Okay, I'm going to click OK. Yeah, okay, you notice that my icon has changed already to this AE. Now, quickly, I'm not finished yet. Very fast, coming 12 o'clock. Okay, come. So what I do is I need to do the terminal mapping. I need to map out this terminal. Now, I suggest you don't change the terminal setup. Okay, this terminal that is normally used is called 4224. Just for your information. 4 times. It's usually called 4224. What does it mean? 4224. Do you see this thing or not? This terminal. You can imagine. What is 4224? Make a guess. Anyone? What is 4224? You see this terminal, right? You can actually choose one, You can choose the terminal pattern. You see, if I right click, go to the pattern, right? Don't use the other funny type. Now I tell you, I never seen anybody use a 28 terminal LabVIEW front panel. This one, I think I never see in my whole 23 years of programming career in LabVIEW. I never see anybody use this. It's ridiculous. You know why? This one got 28 terminal. To be honest, you go and count 28. I don't want to count 28. Why I say silly? If you're using this, you don't need so many.
Yeah, I
right?
don't need so many. Yeah,
it's ridiculous. If somebody use 28 terminal, I tell you, likelihood is that this code is going to be spaghetti code. Okay, because there's a lot of wires and stuff, and it's super messy. Okay, a bit crazy lah. You ask me. Okay, so don't use this one. So the default is 4224. 4224 means what? You see carefully. You study this thing carefully. 4 means what? 4 inputs. Very simple. There are 4 on the left hand side. There are 4 input terminals. Okay, 2 means 2 at the top there. Okay, right at the top. The top there, you see a rectangle box, right? Bigger, right? There's 2 terminal at the top there. Then there's 2 terminal at the middle bottom. Okay, the middle center there got 2 terminal. The middle bottom there got 2 terminal. Then 4 terminal for the output. Therefore, I call it 4224. This configuration is perfectly fine. Okay, don't change it. Use this one. Use the default terminal. Okay, so remember 4224. Okay, 4224 is not a 4D number. Okay, so 4224. Okay, so keep that way. Then after that, quickly do the wiring tool. We're almost done already. Okay. Don't know y'all fatigued already or not. Okay, quickly use the wiring tool. You know where the wiring tool? Use the wiring tool. Click on this little wire. Okay, launch the tools palette. Right click. Okay, tools palette. Right. Use the wiring tool. click on this wire. This part you have to do carefully. Usually the functional state. Okay, I recommend you click on this one first. Click first. So make sure it's highlighted, right? Now I want you to slowly move. Carefully do it properly. Bring your wiring tool to the input terminal. Choose the center one, the center middle. Okay, so I click on this. It will change color. Do you see? Okay, I repeat one more time. This one must do carefully. Use the wire. You can start from here also can. Okay, maybe start from here up to you. Use the wiring tool. Click on the terminal that you want to associate. So I want this center, this one black. I see I selected item black. I want the center one. Okay, select this one for the functional state. Then you bring your mouse, click on this function. The thing will change color. Not so significant, but it does. It's already mapped already. This one mapped to here. Okay, so I want my counter output here, which is this fella here. Click on this guy and bring it to the far top right hand corner, that one. So I click. There you see it changed color. Okay, and then okay, hey, y'all having problem this one?
Okay.
Can so far so good
Okay.
Okay, and then lastly, the two arrow in, arrow out, right? One of each, right? So I click on the bottom there. Use this standard position. The arrow in always at the bottom left hand corner. So I click on this one. Okay, and then finally the arrow out. Click on this terminal. Click on this one. Okay, done. So this is my sub VI. So I save first. Go to File, Save. Okay, so I got this action engine already. Done. So I tested it. It's working. It's modular. And it's reusable. I'm very happy with this. So how do I test this in the main program? So this one done already. This action engine done already. Sorry. So let's test it, right? You all tested it already, right? So close. I'm going to call this in my main program now. How to call? Okay, can you open up just now you have a blank VI? This is my main program. So this thing can close already. If you want, you can close it. Okay, you can close or you can, there's two ways to call the sub VI lah. Okay, quickly okay, now I'm not sure if you all fatigued already. These two okay, this one okay, so I got one main program, right, which is this is just a picture. You know how I put the picture there? Don't know how to put picture? Sorry, I didn't explain this part, right? Do you know how to put picture in LabVIEW?
No.
You know, okay, I share you. I do one more time, I show you this one, how I put this picture on. Okay, how I put the picture in LabVIEW. Very simple. First of all, obviously, you must have the picture first. Okay, you must have the picture ready. So what you do is you go to Edit, you import picture to clipboard. Okay, you click on this import picture, then you select the picture. Where is the picture? So for me, I put it on my desktop or any picture. You can go and try. So just now I screenshot, I call it capture. I select this picture, I click OK, right? So this picture is imported into your clipboard. Then now I go to Edit, I paste. Very simple only. There. So it's a simple import and paste. Okay. So I got this code, this picture here. Any picture you want, you can import any picture you like. So now how do I quickly test the AE? So I go to my while loop, right? Create a while loop. Now this is my main program, so I must now create a control for it. Okay, this is my main program running. Okay, there's a control button. Okay, now how do I call the sub VI or the action engine? Very simple. Right click, select a VI. Do you see? Okay, select a VI, click on this, select a VI, then you can navigate to where that your file is. So just now the folder is called simple action engine called AE, right? This one. You can select this, click on this VI, click OK, then it will come out already there. This action, this particular AE. Then I can also turn on the label. And this is the AE counter I created. You can hover to your show context help, then it will show you all the terminal. This is the thing that you have created just now, or I created. Okay, so how do I test this thing? It's already tested just now. So you can bring your AE counter right outside first. Okay, so I can populate this one. I can right click on the functional state here, right click, create constant. Okay, so what is the first state? Initialize, right? So then I wire this error to here, something like that. Okay, so I know internally initialize means to set the value to 0. So you don't need to go and figure out already, because all this is done internally inside using the shift register just now that you've done. Okay, so maybe now I simulate. I quickly simulate using some switches. Maybe I use a mechanical switch here. I call it a switch. I call it maybe an increment switch. Okay, so I created a switch very quickly. Okay, I created a switch. Okay, so this switch is now this is my main program. Okay, I put a K structure. Okay, I put a K structure. Let's say now I'm going to use that to display the. So when this mechanical switch to simulate the sensor, so I right click, I change the mechanical action. I want it to be, I don't want press, I call it latch. I use the latch action so that the switch will toggle. So imagine now I got this switch. Why I call it increment? Just call it. Oh, okay, increment switch is fine. Okay, so I wire this guy to here. Okay, so when it's true, I want the AE. So what I do is I just copy the AE. I put the AE inside. Notice that I use the same AE, the same action that you just now you have created. But now I'm going to change the state. So when it's called increment, I increment. Okay, I increment. I call the increment. Then I display the counter value. Right, I pushed out the value. Now this value, right? Right click. I create an indicator to display the value. The action engine will do for me whatever that's inside. Okay, right? You see I put the counter value here. Right, this counter. Okay, put here. Now when I click is increment, right? So that means this switch the default is retain value. Okay, then the other value is to increment. Okay, there are two states. Okay, later you will see what I'm trying to do. So when it's false, if it's true, you increment. If it's false, what do I do?
Retain.
If it's retain, correct. So I put the AE inside here called retain. Okay, then I'm done already. So I don't want to do the other thing first. The decrement, maybe y'all can do. Okay, done. So my code ends like here. Almost I put a wait millisecond here. So I fast forward a little bit. In the interest of time, I want to make y'all fatigue after a while. Long already. Okay. So now I run this thing. So you can see that when I run. Okay. This is that you initialize from the outside first. Then he will default is false. The increment switch here default is false. So if I click on this guy, he will click one time. You see what happened? Then he will click one time. Then the switch will come back down because it's a latch action. So then he will increase 1. You see? So if I switch off the highlight execution, you go and play yourself. You go and turn on. So what I do is you see watch. I click, it will increase. You see? I click, it increase. I click, increase. I click, it increment. Otherwise, it retains the value. You see? Yeah. Okay. I click, it increase. Yeah. So you notice that the main thing is that I used an action engine. Okay, to do all the necessary action, so that I keep my main my main calling program very short and sweet. Okay, this is the main program. It's very neat and tidy. I put the action inside the action engine. So in my main program, I got very few wires, and the program is very manageable, and I can reuse this AE. Any question? Maybe I pause for a while. Quickly, I want to end it in a couple of minutes time. The recording quite long. Later it will be very big file. Okay, by the way. Yeah, any questions so far? Any question from you people, please? So far so good. Or any question, feel free to ask. Or you need more time to digest, I also agree, because sometimes it's a lot of things here. It's a simple program like an action engine, just a counter. It has some concept behind it. Anchong, any question? Maybe I just go around. Anchong, question?
No.
So far, okay. So far, you think you answer. Okay, Yulong, any question?
No question.
No question. Okay. Idel, anything?
I go and rewatch.
Okay, I understand. So sometimes you may need to rewatch. You may not understand the first time. Okay, so I'm perfectly fine with that. Richmond, any questions so far?
The counter, right?
Yes.
The initialize and the reset is the same code.
Yes, correct. The initialize and the counter reset, actually they are the same thing. But I just do it for illustration. Actually, you just need one.
Okay.
Yeah, you are right. You are very sharp. You saw it. Yeah, the initialize thing that we did and the counter reset, actually they are the same thing.
Okay.
Okay, you can actually remove the counter reset. You just put initialize, the same thing. You're right.
Yeah. Okay.
Okay, well spotted. Correct. Okay, so you can just eliminate one step. But just for completeness, I just want to show lah.
Okay.
Okay, can
Yeah.
Okay, I tell you what. I think I will stop here. Maybe y'all overload. I'm not surprised. Maybe some of you are a bit overload already. Okay, never mind. I let y'all slowly watch first. Y'all can take a few days, or maybe watch it over the weekend. Then you got any question, you ask me back again. Is that okay? I hope y'all find this session useful.
Yeah, okay.
Yeah.
Okay,
Right.
we will try to do a bit. I won't say bite size. Also really like 1 hour already. Quite long. Yeah. Sorry. Okay. But I wanted to take time to explain slowly to y'all. That's the thing. That's my intention. Explain slowly so you all understand it. Then y'all, after you understand this, you master this, right? You can create your own already. You know what I mean? I want to teach you to fish. I don't want to teach you. I don't want to give you a fish. You know, there's a saying, right?
Yeah.
You all heard, right? There's a saying. I can give you a fish to eat, but you only eat one day. I don't want that. I want to teach you how to fish, so that you can go out and catch your own fish. Inverted comma. Oh, you understand?
Yes.
Yeah.
That's my main intention, so that y'all can become self-independent and y'all can develop your own codes using the existing knowledge. So I would rather go slow and then explain to you first. Then you understand, then you can go on and develop your own codes with little help, so-called. Okay. I think with that, I will save this code. I will zip this thing and send to all of you. And I hope you all find this session useful. Okay? If
Yeah.
question, I think I will end the session and I will stop the recording. The recording quite a while. Okay, can
Yeah.
have a good lunch and we will keep in contact again. Anything, just WhatsApp me.
Can.
Okay.
Alright. Okay, thank you. I will send you the video. Send you a link to the video and the VI also. Okay, can thanks.
Thank you.
I will stop
Thank you.
here.
Thank you.
Yeah, thank you. You can go off already. Thank you.
Bye.
Bye.
Thank you. Bye bye.